The AQA GCSE Maths Higher Tier Paper 2. Let's run through it. Question 1. Circle the factor of x squared minus 5x. Well, we've got a common factor of x, so if we take out x, we're going to be left with x minus 5. So the answer must be x minus 5. Question 2. A is half of b. Work out the ratio a to b, circle your answer. Well, for the first one, if we say b is 2, well 1 is half of 2, and that's correct, so it must be this one. It can't be the second one, as b is 1 and 2 isn't half of 1, so it's not this one. For the third one, 1 is not half of 3, in fact it's a third of 3, so it can't be this one. And for the fourth one, 3 is actually 3 times lots of b, because it's 3 times 1, so it can't be this one either. Question 3. The first 3 terms of a geometric progression are 2/3, 4/9, and 8/27. Circle the fourth term. Well, notice all the denominators in the options are 81. I'm just going to look at the denominators first for the question. So we've got 3. Well, if we times it by 3, we'll get to 9. If we times it by 3, we'll get to 27. If we times it by 3 again, we'll get to 81. Looking at the numerators, well, 2, it could be add 2 to get to 4, but it's likely, because its progression is going to be multiplied, and it's by 2. 4 times 2 is 8, so this must be the sequence. So 8 times by 2 must be 16. So the answer is 16 over 81. Question 4. Circle the reason why these triangles are congruent. Well, the information we've been given is just sides, so it can't involve angles for the reasoning. So it can't be ASA because that's angle side angle. It can't be side angle side, so it can't be this one either. We don't know if it's got a right angle in it, so it can't be right hand side either. So it must be side side side. We can confirm this because these 3 have a side each. These 3 have a side each. So this is the only way we can check whether they're congruent or not. Question 5. Solve 10x equals 62.4 minus 3x. Well, my first step, I'm going to add 3x to both sides. So that will leave us with 13x equals 62.4. We then need to divide both sides by 13 to leave us with x. So that will leave us with x equals 4.8. Doing 62.4 divided by 13 in your calculator. Question 6. Lines A, B, C, D and E intersect as shown. Lines A and B are parallel. So actually this line here and this line here are both parallel. This is really important in a short while. So what it says to work out the size of angle X, which we can see here. Well, let's figure out what we do know. Looking at this 52 degrees here, we've got this X here, so we can actually safely say, well, this must also be 52 degrees. Same thing here, at this 49 degrees, there's an X angle here, so this is also 49 degrees. We've got this here, 110 degrees on a straight line. A straight line is 180 degrees, so this must be 180, take away 110, which is 70 degrees. We now need to use our knowledge of alternate angles and corresponding angles. So we want to figure out, well, if we've got this X here, we need to find what this angle is here and what this angle is here. I'm going to focus on this bit over here to try and find out this angle first. So if you think of alternate angles, which are Z angles, we can actually see here, I'm going to highlight this, so we've got, there we go, we've got 70 degrees here, which must mean 70 degrees is also here, because of these 2 parallel lines. And if this is 70 degrees, well, we've got this X here, so this must also be 70 degrees. And because we've got this X here, these 2 angles must also be the same as each other. So this angle must be the same as this angle. We know there's 360 degrees all the way around, so all of these must add up to 360. So we can say, well, 360, take away 70, take away the other 70, take away 52, take away the other 52, leaves us with 116 degrees. Now the 116 degrees is this and this. So we need to half 116 to find the amount. So we've got 116 divided by 2 equals 58 degrees. So this must be 58 degrees, and this must also be 58 degrees. Now we still need to find this angle here. But what could this angle be? Well, remember these two are parallel lines. If we just focus on this bit then, I'm going to highlight this. So we've got this, this, and then this. We can actually see we've got alternate angles. So this 49 degrees must be the same as this angle here. So this is 49 degrees. Finally then, we've got this angle, and we need to find this angle. Well, we know angles in a triangle add up to 180 degrees. So we can use this last bit of information, I'm going to scroll down the page a little, to say, well, 180, take away the 58 degrees we figured out, take away the 49 degrees we also figured out, will leave us with 73 degrees. And that is our final answer for this question. The angle X equals 73 degrees. Question 7. 102 boys and 85 girls took a test. The table shows information about the mean marks. We've got this in the table here. The pass mark for the test was 70. Was the mean mark for all of these students greater than the pass mark? And it says you must show your working. Now, you can't just add these two mean marks and divide them by 2, because the proportion of boys is not the exact same as the proportion of girls. So what we need to do is find the total of marks that the boys have and the total marks that the girls have. So we'll start off by working out the total marks the boys have. So the boys, they have, well, there's 102 students with an average mark of 68.5. Enter that into your calculator. We've got a total marks of 6,987. And then for the girls, well, there's 85 girls multiplied by their average marks, so that's 72.4, which equals 6,154. So we now know the total marks the boys and the girls each have. We now need to find the total they both have, which is 6,987 plus 6,154, which gives us a nice number. Well, maybe not so much, but in your calculator it will come out with 13,141. So this is our total marks. Now that we've done that, we have to say, well, what is the mean marks? We know the total number of marks, but how do we find the mean? Well, we need to find out how many students there are altogether. Well, we know there are 102 boys and 85 girls, which gives us 187 students in total. So what we can now say to find the mean mark is 13,141, so the total marks divided by the total number of students. So 13,141 divided by 187, and then your calculator, that will come out as 70.27. Now looking back to the question, because we've now found the mean mark, and the question asks, was the mean mark for all of these students greater than the pass mark? Well, 70.27 is greater than the pass mark, which was 70. So, on average, the mean marks for all students was greater than 70. You'll get a mark for either one of these. You'll get a mark for this part here. You'll get a mark for this value, and you'll get a mark for this alongside this. Question 8. Describe fully the single transformation that maps triangle ABC, so ABC, to triangle ADE. Well, we can see straight away one is bigger than the other. So we can instantly say, well, the transformation must be an enlargement. The next thing we need to state is from which point. So from point. So where is this point? Well, we can see by observation the triangle starts at this point here for both of them. So it must have been enlarged from here. you can also draw some straight lines which would cross over at this point A. So therefore, the enlargement is from point A. You don't have to write A for this, but I'm just going to anyway. So from A, which is 0.39. So we've got 2 bits of information, but we've got 3 marks in total. So our third bit of information needs to state what the scale factor is. So the scale factor for this one, well, ABC becomes ADE. So it actually gets smaller. So the scale factor is going to be smaller, so we can probably assume it's a fraction. Well, I'm going to count here. So we've got from A, it goes down 1, 2. So that's 2. And then 3, 4, 5, 6, 7, 8. From here, it's 8. So our scale factor is 2 over 8, because it's smaller, because it's now 2 and it was 8. But we can simplify this to 1 over 4. So our scale factor is 1 over 4, or if you prefer, 0.25. So you'll get a mark for enlargement, a mark for the point, and a mark for the scale factor. Question 9. A ball contains 5,000 centimetres cubed of air. More air is pumped into the ball at a rate of 160 centimetres cubed per second. The ball is full of air when it becomes a sphere with radius 15 centimetres. The volume of the sphere is 4/3 pi r cubed, where r is the radius, so it's given us the formula, which is quite nice. Does it take less than 1 minute to fill the ball? You must show your workings. So what we need to figure out here is how much air will be in the ball after it's been filled up with air. We know how much air is currently in it, but we want to know how much air will be in it once it's filled up. So that will be our first point of call. So the volume after it's been filled up, it's going to be 4/3 pi r cubed, which is 4/3 times pi times the radius cubed. The radius for this, it's given us, is 15 cubed, which, typing that into your calculator, will give us 14,137 to the nearest whole number, and that will be centimetres cubed. So that's 1 mark already. We now need to calculate how much air is going to be filled in the ball now. Well, the total air that will be in it will be 14,137, and the amount of air that's already in it is 5,000. So we can take away the 5,000 to figure out how much air is going to be filled into the balloon, into the balls, which is 9,137 centimetres cubed. Our final step then, we need to figure out how long it's going to take to fill the bowl with the remaining air. So 9,137 is the amount of air, and it's going to be filled at a rate of 160. So we can do the equation, or the calculation, 9,137 divided by 160, because that's how much will be filled per second. Put that into your calculator, and that will give us 57.1, and that will be seconds, because it's given us the time. So it's the amount of time it will take to do it. So 57.1 seconds is the amount of time it will take. And our question is, does it take less than 1 minute to fill the ball? And our answer is yes, it takes less than 1 minute. Question 10. P is a positive number and N is a negative number. For each statement, tick the correct box. I'm going to tick whether it's always true, sometimes true, or never true. So I'm going to say, well, if P is a positive number, I'm just going to use 2 or 1. And if N is a negative number, I'm going to use 3 or, negative 3 or negative 1. So I'm going to input values into each of these just to test it. So P plus N is positive. I'm going to try plus 2 plus minus 3, which equals plus 2 take away 3, which equals minus 1. So we can already say, well, it's not always positive, so it can't be this one. I'm going to use, let's say, plus 2 and then plus minus 1, which actually is plus 2 take away 1, which equals positive 1. So that becomes a positive. So we can now state that it is sometimes true. P take away n is positive, and we use other numbers, so let's say plus 2 take away minus 3. Well, that becomes plus 2 plus 3, which becomes plus 5. So we can actually say, yes, it's always true. P squared plus n squared, well, we've got, let's say, 2 squared plus minus 3 squared, well, 2 times 2 is 4, and minus 3 times minus 3 is positive 9. So squaring a negative number is always going to give you a positive number. So therefore, this has to be always true. And lastly, p cubed divided by n cubed, I'm going to use plus 2 cubed and divided by, I'm going to use negative 1 cubed for this. So 2 cubed is 8. Negative 1 cubed is negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1. So that will become divided by negative 1, which will give us a negative number. So p cubed divided by n cubed, or positive cubed divided by a negative cubed, will never equal a positive. So it's never true. Question 11. 250 trains arrived at a station. The number of trains that were late was recorded after every 50 trains. The table shows some information about the results, as we can see here. Complete the relative frequency graph. Now the first step we want to do is complete this table at the top here. Now the way to do this is quite nice really. We can say, well, if this is the relative frequency, I like to think of these as percentages. So 32% of these 50 trains were late, or 16 out of 50 were late. So the calculation for this was 16 divided by 50 equals 0.32. Same for this second column here. 21 divided by 100 equals 0.21. So this is 21% of these 100 trains were late. And for this one, we're going to do 36 divided by 150, which equals 0.24, or 24%. For this one, it's going to be 38 divided by 200, which equals 0.19. And for this one, it's going to be 55 divided by 250, which is 0.22. So now we've got these values, we can input them into this graph. So you want to be as accurate as you possibly can. So we've got total number of trains on the bottom and the relative frequency of late trains on the left, or the y-axis. So the first one, we've got the first two plotted. So the next one we need to plot is the number of trains is 150 along the bottom. I'm going to go up to 0.24, which is here. And then the next one is 200 trains and 0.19, that is here. And then 250 and 0.22, which is here. And then what you want to do is connect this graph up. Make sure you use a ruler for this, as it's very important that you get this accurate and make sure the lines are straight. Mine are a little bit dodgy, but that's just because of the software I'm using. But that's it, that's all 3 marks done. So now for question B, write down the best estimate of the probability that a train arriving at the station is late. So the best estimate is going to use the biggest amount of data. Well, this 250 here, that's the total amount of trains that were observed. Out of the total 250 trains, 55 were late. So we can say the best probability we can use is 0.22, because 22% of those trains were late. So we're using the biggest amount of data, because we've used the biggest amount of data, all 250 trains, rather than a smaller sample. So 0.22 is the probability. Question 12, A, B and C are 3 points on a circle. The radii from A, B and C are shown. So A, B and C. So they're all radii, or radiuses if you want to use English incorrectly. So is AC a diameter, so is AC this line here, a diameter of the circle? You must show your workings. So you're saying, is this a diameter? Does it go through the centre? Well, we know all these points are from the centre because they're all radii. But is this a straight line, or is this A a bit like this B? It's a bit askew, so it's not a straight line. and it's more like this. So we need to figure out, well, how do we know this will go through the centre? We know there's 360 degrees in a circle, but in a straight line we also know that there's 180 degrees. So there's now two ways we could go about this. We could say, well, the total of all of these values must add up to 360, or this must equal 180. I'm going to show you both ways. So I'm going to show you where all of this equals 360. So we're going to start with adding them all up. So we've got 5x plus 40 plus the x, and then plus the two lots of 2x plus 20. Simplify that, so we've currently got 6x plus 40 plus 4x plus 40. Simplify that further, so we'll have 10x, and then 40 plus 40 is 80, so plus 80. And what we want to say is this must equal 360. We know it equals 360. And now we just have to, calculate it or rearrange and solve for x. So we're going to take away 80 from both sides, and that will leave us with 10x equals 280. Divide both sides by 10, that will leave us with x equals 28. So now we know what x is, which is 28 degrees. What we need to say is, well, does this 5x plus 40 equal 180 once we input this x? So we'll say, so inputs x equals 28, and we'll say 5 lots, trying to keep it all on one screen, 5 lots of 28 plus 40. I'm going to try and solve what that is. So 5 times 28 equals 140. And then we've got plus 40. And then 140 plus 40 equals 180 degrees. Oh, so it does equal 180 degrees. Therefore, AC, that's what was our question, AC is AC diameter of the circle. So, yep, AC is a diameter of the circle. Now, the second way of doing this is very similar, but how I explained at the start. We're going to assume that this 5x plus 40 at the top here is 180. So we'll say 5x plus 40 we'll assume to be 180 degrees. Take away 40 from both sides, so 5x equals 140. Divide both sides by 5, so x equals 28. So we already know already, x was 28 before, so we're doing something right because we're getting the same values. But what we want to do is input this 28 into everything, because all this is meant to equal 360. So we'll say we've got 5 lots of 28 plus 40 plus x, which is, we know is 28 now, plus 2 lots of 2x, so 2 lots of 28 plus 20. Type that into your calculator or work it out bit by bit, and what you'll get is a total of 360 degrees. Now, because that's 360 degrees, we can safely assume that this must also be 180, because we assumed it was 180 at the start, and the total, once we found the value of x, is 360. So therefore, that's the second way we've discovered or proven that AC is a diameter of the circle. Question 13, a straight line has a gradient of 6 and it passes through the point 319. Work out the equation of the line. Give your answer in the form y equals mx plus c. So it's another one of these lovely y equals mx plus c equations. We already know the gradient, so I'm going to input that. So it's y equals 6x plus c, because the gradient, or m, equals 6. And we also know what x, our single point, one coordinate of x, so we can use the x value of 3 and the y value of 19 and input that into our equation. So y is 19, so 19 equals 6 lots of x being 3, and then plus c. So we can solve this now for c. Well, we've got 19 equals 18 plus c, take away 18 from both sides now, so we're left with 1 equals C. So now we know C, we can input it into our final y equals mx plus c format, which is y equals 6x plus 1. The population of butterflies in a park is 4,200. Assume that the population increases by 12% each day. Show that after 20 days the population would be greater than 40,000. This is a really nice calculator question, to be honest with you. It's involving your percentages knowledge. So we've got 4,200 is our amount to begin with. And each day it increases by 12%. So that's, we'll have 112% in the second day. And then 112% of the third day compared to the second day. So we're timesing it by 1.12. Now that's the amount if you're timesing it to find the amount in the second day, but we're trying to find out the amount after 20 days. So it's times 1.12 times 1.12, 20 times. So we're doing 1.12 to the power of 20. And that will give us a value of 40,514. So we've now shown that after 20 days, the population would be greater than 40,000 by exactly 514. Part B says, in fact, the population increases by 13% each day for 19 days, then decreases by 8% for 1 day. After 20 days, is the actual population greater than 40,000? So let's have a look. Well, we need to recalculate with the starting population was 4,200. So 4,200. I'm going to multiply it by 1.13 because it increases by 13%. So the 100% add the 13%, and that's over 19 days or after 19 days. Calculate that, and that will be 42,829. But then on the last day, it decreases by 8%. So 42,000, or on the 20th day, I should say, is 42,829 multiplied, well, it's 8% decrease, that's 100%, take away 8%, which is 92%. So times by 0.92, which will give us 39,403. That's rounded. If you really want to, though, you can do this all in one go. So you can say 4,200 multiplied by 1.13 to the power of 19, and then multiply by 0.92, and you'll also get the same answer. (14C), it says the expected number of visitors to the park each day depends on the temperature. I think we can all expect that. On each of the 30 days in June, the park is open, and the probability that the temperature is less than 21 degrees is 0.4. Work out the total number of expected visitors to the park in June. A few ways you could go about this. I'm just going to show you one method for this one. So I'm going to say, well, how many days was it less than 21 degrees, and how many days was it more equal to or more than 21 degrees? So we've got 30 days in total, so I'm going to work out for less than 21 degrees first. So 30 days in total, and there's a 0.4 chance that it's going to be less than 21 degrees, and that will be 12 days. Probability that it's greater than or equal to 21 degrees will be 30 days multiplied by 0.6, because the days is not less than 21. Or you could just do 30 take away 12. Either way, you'll get 18 days. So now we know what the temperature will be over the month. There'll be 12 days for less than 21 and 18 days for more than or equal to 21 degrees. We now need to figure out the total number of expected visitors to the park in June by working out how many people will come during each set of temperature days. So we've got 12 days, for less than 21 degrees, we've got 12 days where there'll be 700 visitors. So 12 times 700, which is 8,400. And for the more than or equal to 21 degrees, there are going to be more visitors, which is 18 multiplied by 900, which we've got from the table there, which is going to be 16,200. So we know the total number of people over the 12 days and the 18 days. So therefore, if we add them both together, we're going to get a nice grand total of 24,600 visitors. Question 15. L is directly proportional to D squared. L is 85 when D is 10. Work out an equation connecting L and D. So we know that L is directly proportional to D squared. So we can write the equation L equals K, a constant, multiplied by D squared. So we need to figure out what this K value is. Well, we know the value of L, which is 85, which is K lots of D squared, and D is 10 when L is 85, so that'll be 10 squared. So we've got 85 equals 10 squared is 100, so 100K. So therefore, divide both sides by 100, we'll have 85 over 100 equals K. So now we know K, we can input this K back into the equation. So therefore, L equals 0.85 D squared. 85 over 100 being 0.85. Some of you may have done this differently. You may have done it the other way. So you may have got the answer of 100 over 85 L equals D squared. Both of these are correct, but I prefer it this way, particularly because it comes into play in the second question and makes it a bit easier. So for question 15b, it says work out the value of L when D equals 5. So now we've got the equation, we just have to input D. So L is 0.85 D squared, so L is 0.85 D, which is in this case 5, so 5 squared. And therefore L is 0.85 times 25, so therefore L is 21.25. Question 16 now. Now, it says here is a cube with edge length x centimetres and one diagonal is shown. Circle the length in centimetres of the diagonal. Now, I don't really like this question for 1 mark because I think it's a little bit mean. If you're not sure how to do it, you have to sort of figure it out algebraically. I'm going to show you how this works exactly, and then you'll know why the answer is. So we've got this length here, which is the diagonal from one edge to the other. But in order to do that, we're going to want to find this. We're going to use Pythagoras for this. We want to find this length here, so we've got a right angle here. But in order to find that, it's going to be the hypotenuse of another length, which I'm going to use this length and this length. So I'm going to call this length h. So we'll have, using Pythagoras, h squared is a squared plus b squared, in this case x squared plus x squared. So h squared is 2x squared. And therefore, if we square root both sides, we'll have h equals square root of 2x. So h is root 2x. If I draw out this triangle now, we've then got side root 2x, x, and we're trying to find this side here, which I'm going to call red, because why not? So we've then Pythagoras again, we've got the red side squared equals x squared plus root 2x squared. So that equals x squared plus 2x squared, because squaring the root 2 gets it out of the brackets again. So red squared equals that. Square root both sides, so you'll have the red side. Oh, before that, what we want to do is simplify it. So we'll have 3 lots of x squared, and then we square root it. So red then equals square root of 3x. And there we are. And we've got the answer here, which is root 3x. Quite a mean one for 1 mark. If you know the answer off the top of your head, that's really nice. If not, I've shown you the algebraic way of why that is. The total length in centimetres of the edges of the cube is a multiple of 18. Circle the correct statement. So x is a whole number, x is not a whole number, or x might be a whole number. Now this is quite a horrible question for 1 mark if you have to, but luckily you don't have to prove anything. So what we're going to say is, well, it could be a whole... It can't not be a whole number, because if it's a multiple of 18, it could be a huge number, for instance. So it might get rid of all the decimals. If we're saying if it's a whole number, well, we're going to say, well, there's 12 edges on a cube, which has to be a multiple of 18. So n is the missing number, we don't know, but we're saying it's a multiple of 18. If I rearrange that, we'll say x equals 18n over 12. And then we'll simplify that down, which will become x equals 3n over 2. 3 over 2, that's not a whole number. That's actually, it becomes a decimal, which is 1.5. So technically, it could be a whole number. It might be a whole number, but it might not be. So it's not a whole number for sure. So we can say it's not going to be a whole number for sure or not for sure, so it has to be a maybe. So there's our mark. Question 17. 20 people were asked which device they use more often, laptop or phone. I'm guessing most people these days would use the phone. So here's the table of results. One male and one female are chosen at random. Work out the probability that exactly one of them said laptop. So I'm going to work from the top row first and work down. So I'm going to work out the probability first that there is one male has chosen laptop. Well, we've got firstly, let's find out the total of males. Well, 2 plus 9 is 11, and total of females, 4 plus 5 is 9. But yet, 20 people, 11 plus 9 is 20. Brilliant. So I'm going to use a probability tree. It's going to say the probability that a male chose, a laptop is, it's going to be, well, it's 2 out of the total number of males, which is 11, and then a male chose a phone is 9 out of 11. So 2 out of 11 chance a male chose a laptop. Secondly, from this tree, we're going to say, well, probability a female chose a laptop. So female chose a laptop is, well, there's 4 females chose a laptop out of a total of 9 of them, and a female chose a phone, while there's 5 out of a total 9 females. This will be the same, 4 out of 9, 5 out of 9. Female laptop, female phone. Now we want to work out the probability that exactly one of them said laptop. So if it's just one of them, that means if a male chose it, a female didn't. If a female chose it, a male didn't. So I'm going to start off with if a male chose a laptop, which is 2 out of 11, the female didn't. And then if the male chose a phone, the female didn't. So we can use this. So it's going to be this probability here and this probability here. So this will be 2 out of 11, which is the probability the male chose a laptop, multiplied that the probability that a female chose a phone, or didn't choose a laptop, which will become 10 over 99. And then the second probability, we've got the male didn't choose a phone, which is the male did choose a phone, didn't choose a laptop, is 9 out of 11, multiplied by the female chose a laptop, which is 4 over 9. And that's, well, 9 times 4 is 36. 9 times 11 is 99. So we've got lovely numbers in the denominators. So we've got the probability that of each one. So we now need to say, well, what's the total probability? Well, that's going to be 10 over 99 plus 36 over 99 equals 46 over 99. And that is the probability that that's the probability that exactly one of them said laptop, which is 46 over 99. Leave it as a fraction form because that's exact. If you round it, you'll still get the marks, but you've got to be careful with rounding. Probably leave it to at least 3 decimal places. But in this case, I'd just leave it as a fraction because it's much safer. Or as a safer bet. For 17b, 2 males are chosen at random. Work out the probability that they both said phone. Okay, so for this one, we're just focusing on the males here. So we've got 2 and 9. So let's put 2 and 9 so we can see that down here. So laptop and phone. So it's a total of 11. So we're going to start with probability tree. So if they said laptop, there's going to be a 2 out of 11 chance that they said laptop. And if they said phone, there'll be a 9 out of 11 chance that they said phone. So we've got the probability so far. And now this is where you've got to be so careful. So the probability, well, they said we're choosing 2 people. If one person's been picked, we're not going to count that person again. So we're left with 10 males left. So out of 10, Just going to rewrite that out of 10 out of 10. And if one's chosen a laptop, then the other person, there's only one person left to choose a laptop, but there are still the other 9 people left to choose the phone. Same at the bottom here, so we've got the phone, 9 people chose that. So if another person chose the phone again, so there's only 8 people left to choose the phone. So there's still the 2 people left who chose laptop. So if we said the probability that they both said phone, we're looking, well, if we go down the tree, one said phone, the second said phone. So we're looking for this value, which is going to be here, which is 9 over 11, the probability that one picked phone, multiply the probability that the second person picked phone as well. 9 times 8, which is 72. And 11 times 10, which is 110. You can simplify that down to 36 over 55. And that is our final answer, 36 over 55. Again, leave it as a fraction because it's an inexact numerical form. If you round it, you're more prone to errors. Alright, question 18. On the grid, identify the region represented by x is less than or equal to 5, y is less than or equal to 4, and x plus y is greater than 6. So I'm going to identify the region x is less than or equal to 5. So we've got the x axis along the bottom. When x is 5, it's just going to be this line here. So I'm going to draw that on. So when x equals 5, I'm going to draw on. So when x is less than or equal to 5, it's going to be everything that section back. So it can't be this section here. Next, we'll draw on y is less than or equal to 4. So it has to be this line here. And if it's less than 4, it's going to be this region downwards. The last line is x plus y is greater than 6. Now this one's a little bit trickier. If you're not sure where this line is, just draw a little graph. So we've got x and y. So we've got, if x is, we'll say 0, 1, 2, 3, you can keep going. But x plus y must equal 6. So 0 plus 6 equals 6. 1 plus 5 equals 6. 2 plus 4, 3. And also when y is 0, x has to be 6. So we're going to have the line from this point to this point here. And it's stating that x plus y is greater than 6. So it must be all this value up here. So the region R, we can see from the lines, must be this region here. Because it's left of this, down from this, and up from this. Question 19 is a little tricky. The graph shows the height above ground of a toy rocket for 10 seconds. For how long is the rocket in the air? Circle your answer. So we've got the answers of 10, 9, 6 and 4 seconds. Now we can see if it's in the air, it's going to be higher than 0. So it's in the air between 4 and 10 seconds. So therefore that's a total of 6 seconds. Part B says, using the graph, estimate the speed of the rocket after 6 seconds. To state the units of your answer. So we're going to have to go back to the graph here and say, well, at 6 seconds, I'm going to look from the bottom and go all the way up until the point here. And then I'm going to draw a straight line. I'm going to try and draw it as flat as possible. I'm doing it on the screen, so it's a bit trickier and probably not as accurate, so make sure you do this with a ruler. Now there's going to be a few varied answers here, so don't worry if you've done this and get a slightly different answer, as long as it's fairly close, that's alright. So using the graph, estimate the speed of the rocket after 6 seconds. So if we're looking at the speed, we want to find the gradient of this graph. So I'm going to pick 2 points, which this is quite tricky because it's not the most accurate, which I'm going to pick this one here, which is 7, and if I look across, 11, and actually the original point, which was 6 and 8. So 6, 8, 7, 11, 6 and 8, 7 and 11. So for the gradient of the graph, it's going to be change in y over change in x. I should probably explain why we're finding the gradient. It's because we're finding, if we've got the height over here and the time, we can actually find the units or the time or the height over a certain period of time. It's going to speed up, speed up, speed up, and then it starts to slow down a bit. And then obviously at this point we can see the line would be flat, so it's not actually moving, it's just stopped, even if it's for a moment in time. And then we can see it's going to speed up again and go down. So the gradient can show us the actual speed at this particular point in time. So change in y over change in x, so I'm going to do, which will be change in y, which is 11 take away 8, all over 7 take away 6, it's 11 take 8, 7 take 6, which is 11 take away 8 is 3, and 7 take away 6 is 1, so therefore the gradient is 3. You'll also probably get 3, around 3, it may be between 2.5 and 3.5. Don't worry too much, it's going to be a bit of a rough guess because we're just drawing it on the graph, so it's always going to be a rough guesstimate really. We need to state the units of your answer. So if it's 3, it's 3 what? Well, we're going to say it's 3, well, the units in time, so it's going to be in seconds and the height is meters. So 3 meters a second. And that's our final answer. Question 20. A square has an area of 0.25 square meters. So 0.25 meters squared, or square meters. Circle the length in centimeters of one side of the square. Be really careful with this question because going from meters squared to centimeters squared can be, people make mistakes quite a lot because it's not just dividing by 100. So what I would do is keep it meters squared until you've got it back into meters. So if we're saying a square has an area of 0.25 meters squared, so an area, so 0.25 meters squared is the side length squared, let's say. Then we want to square root 0.25 because it's a side times a side, which is because that's side times a side, which is side squared. So that becomes the side is the square root of 0.25, and square root of 0.25 meters is 0.5 meters. So we've got a side length of 0.5 meters. Now you can convert that nicely into centimeters, which is just 50 centimeters. Question 21. X is an integer. Prove that 35 plus 3x plus 1 squared minus 2x lots of 4x minus 3 is a square number. Now, you might think, where on earth do I start with this one? The first step I would always do is think, well, there's lots going on here. Let's simplify this as much as we possibly can. So that's what we're going to do. So we've got 35 plus 3x plus 1 squared. Well, I'm just going to draw a little this here to expand it out. So 3x plus 1, 3x plus 1. So we've got 9x squared plus 3x plus 3x plus 1. So we've then got 9x squared plus 6x plus 1. And then expand the second set of brackets out. So we've got minus 2. Oh, no, we've not. Minus 2x times 4x is minus 8x squared. Because 2 times 4 is 8. X times x is x squared. And then minus 2x minus 3 is positive or plus 6x. Just move that out of the way a minute. We want to simplify this down. So we've got 9x squared. So we've dealt with that. And then we've got 6x and plus 6x. So we've got plus 12x. And then we've got 35 plus 1 is plus 36. Now at this point you might think, well, is this just a quadratic equation? Well, do I use the quadratic equation? Do I complete square? What should I do? You might have to try it a few different ways, but I'd say the first thing you want to do is try completing the square. And the reason being is because you have it in the form x plus a squared plus b. Now, if you have just x plus a on its own, you can say whatever number's inside here, you're going to square this whole number. So it must be a square number. So therefore I think, and if there's nothing at the end, so if it's plus 0, we're just left with this x plus a. So I would say that we're going to do completing the square because this must have come out as +0, or the b value must be +0. So then we can have an x value, which will be a whole number, +6, and that's all being squared. So complete the square for this, which is x plus, well, half of 12 is 6, all squared. I'm going to say, well, 6 squared is 36. And how do we get from 36 to 36? Well, we're adding 0. Oh, if we're adding 0, it's just the same as saying, well, x plus 6 squared. So no matter what value or what integer or whole number x will be, then this must equal, or this will become a square number. So if x was 2, 2 plus 6 is 8, 8 squared is 64. Therefore, this is going to become, this must always be a square number, so therefore this must always become a square number. Not a nice question, to be honest, but I think you can do this. Question 22, Liam is trying to remember a 3-digit code. He knows the rule that the first digit is a cube number, the second digit is a factor of 16, and the third digit is an odd number. Liam tries at random a code that matches the rule. Work out the probability that this is the correct code. The first thing you're going to want to do is find out how many numbers are in each digit. So for the first one, it says the first digit is a cube number. So cube numbers, we've got, well, 1 cubed, 2 cubed, and 3 cubed, let's say. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Oh, it can't be that because that's 2 digits. So we've got 2 numbers for the first one, or 2 possible numbers. The second one, the second digit is a factor of 16. So we've got 1 and 16, 2 and 8, and 4 times 4. And in fact, 16, it can't be that, because that's a 2-digit number. And finally, for the third digit, we've got, it's going to be an odd number, which is just 1, 3, 5, 7, and 9. So we know there's 2 numbers for the first, possible numbers for the first number digit, 4 for the second, and 5 for the third. So we're going to use a probability tree for this. Ooh, let's draw this a bit bigger because we're going to need a bit of space. So Liam tries at random a code that matches the rule. Work out the probability that this is the correct code. I'm going to say, well, let's say it's the correct code. If it's correct for the first digit, he's only got a 1 in 2 chance of getting that first number correct. So it means he's got a 1 in 2 chance of getting it wrong. I'm just going to do the tree from the correct one because that's the only one we need. And the second one, there's a, say correct, correct and not correct. Well, the probability he gets it correct is 1 out of 1, 2, 3, 4. There's 4 possible combinations for that. So there's a 3 out of 4 chance he gets it wrong. And then for the third number, the chance that he gets it correct, well, there's a 1 chance out of 1, 2, 3, 4, 5. So 1 out of 5 chance. Therefore, there's a 4 out of 5 chance he gets it wrong. So we then have 1 out of 2 multiplied by the probability of 1 out of 4, multiplied by the probability of getting the third digit right of 1 out of 5, and that becomes 1 out of a 40 chance he gets the code correct. So our final answer is just 1 out of 40. We're almost there. Question 23. A ship sails from P to Q and then from Q to R. Q is 12 miles from P and on a bearing of 80 degrees. R is 28 miles from Q on a bearing of 155 degrees. Work out the direct distance from P to R. So we are working out this distance here in red. So what we first want to do is say, well, how do we find these angles here, here, and here? Or at least just 1 or 2, because then we can use trigonometry. So what I'd say is, well, we can probably start figuring out some of the angles. What I'm going to do is continue this line down here, continue this line down here. So we've got a 180 degree line. So we can say this angle here is actually, well, 180, I'm going to write this down, 180, take away 155, which gives us 25 degrees. So we know that angle is 25 degrees. We know this angle here is going to be 180, take away 80, which is 100 degrees. What can we do next? Well, we know this line and this line are parallel. So we can use our alternate and corresponding angles. So we've actually got a Z or alternate angle here. So we can say this angle must be 80 degrees. So now we can actually find what Q is. Well, that's really helpful because Q is 80 plus 25, which equals 105 degrees. And actually, Q's the really important one we needed to know. So this is a vital bit of information, because if we redraw the triangle, which will be not like that, because that is far too right-angled, something like that, we've got 105 degrees, we've got 12, and we've got 28 miles. So therefore, we can actually probably see from this triangle on the left that we're going to be using trigonometry, and it's not going to be standard SOHCAHTOA, it's going to be either the sine rule or the cosine rule. Well, we've got two sides and an angle in between, so we're actually going to use the cosine rule. I'm going to write that down, which is a squared equals b squared plus c squared minus 2bc cos a. I'm going to label the sides, so I'm going to say a, b, c, this is angle A. So a squared equals b squared, which is 12 squared, it doesn't matter which way around b and c are, plus 28 squared minus 2 times 12 times 28, so 2 times b times c times cos of the angle, which is 105. Enter that into your calculator and you should get a squared equals 1101.926, etc. And then what you want to do is, because that's not the answer, because that's the answer, that's the side length squared, so you want to square root the answer. So A is actually equal to 33.20 miles to 2 decimal places. So therefore, we can write in our final answer 33.20 miles. And having a little check, if I scroll back up, well, that's 12 miles, that's 28 miles, 33.2 miles, that doesn't seem too far off. It's not too, we know it's going to be bigger than that, but it's going to be smaller than these two added together. Otherwise, this won't be a triangle. It would just be two flat lines against each other. So, yeah, we've done a little check, and that looks about right. The flight of a plane was in 2 stages. The table shows information about the flight. We've got the table here. In total, the flight lasted 2 hours. Work out the value of x. So we've actually got lots of information here. The bits we want to actually focus on are this bit here, because we know the time is 731 over x and 287 over x minus 24. So the time actually, we've been told that that total is 2 hours. So we're going to write 731 over x plus 287 over x minus 24 equals 2. And what we need to do here is rearrange a bit. So I'm going to scroll down so we can just see this. We don't need anything else at the moment. So I'm going to multiply both sides by x to begin with. I'm going to highlight this here. So multiply both sides by x, and that will give us 731 plus 287x plus, equals 2x. And that should actually be over x minus 24. And then we're going to multiply everything by x minus 24 now, so everything else by that. So that will leave us with 731 lots of x minus 24 plus 287x equals 2x lots of x minus 24. This one's a bit of a hefty question, as you can tell. Expand it out, is 731x minus 17,554 plus 287x equals 2x squared minus 48x. Simplifying the left-hand side will give us 1,000 and, I'm going to write it a bit to the right, 1,018x minus 17,554. And that all equals the right-hand side, which is 2x squared minus 48x. We're going to put everything onto one side, so everything's going to be moved to the right-hand side. Taking away 1,018 will give us, so minus 17,554 equals 2x squared minus 1,066x, and then 0, we're going to add 17,554 to both sides to give us 0 equals 2x squared minus 1,066x. 1066, if you're from the UK, you'll probably remember that advert. 17,554, unless that's just me showing my age. Okay, so we've got this now. We've got this equation here. And what we can do with this is to say, well, actually, it looks like a quadratic equation, and that's because it is. So we're going to solve it as one, but actually one step I'm going to make it ever so slightly easier. You don't have to at this stage, but you can do. I'm going to divide everything by 2, because if you divide the left-hand side by 2, it stays as 0. So that's going to become x squared minus 533x plus 8,772, just because it's less numbers for us to deal with. Don't worry, you don't have to do that. And then we're then going to have to input this into the quadratic equation. And that is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Which is x equals plus 533 plus or minus the square root of b squared, which is 533 squared, or minus 533 squared, minus 4 times a, which is 1, times c, which is 8,772, all over 2 times 1. Whether you input this or this into quadratic equation, you're going to get the same values of x that come out at this point. And it being a quadratic equation, this is where you've got to be careful, because you're going to come out with 2 values. You're going to come out with x equals 516 and x also equals 17. So make sure you write those 2 values down. Write both values down on the paper. Whatever you do, it's an exam, write it down. Now, this, obviously, it can't be both. And we've also got to be a bit logical here, because 17, if you input it back into this here, it will work for both. They'll both equal to 2 or 2 hours. But you've also got to think logically, the distance is this. If they're traveling at, x is the speed, which is, if they're traveling at 17 miles per hour, you know they're actually not going to travel 731 miles within 2 hours. In fact, if you do 731 divided by 17, you'll get 43 hours. So 731 miles divided by speed of 17 miles per hour is, so that's 43 hours, so it's definitely not going to be that one. So it has to be the faster one. It has to be 516. And this is the part where your logic has to play a part, or your reasoning skills have to play a part. So 516 is x. Final question, number 25. The equation of a curve is y equals x squared plus 14x plus 52. By completing the square, work out the coordinates of the turning point. You must show your working. Okay, this is quite nice then. So all we have to do to begin with is complete the square. So y equals, well, it's going to be x plus something. Well, it's half of 14, so it's 7 squared. 7 squared is 49. So to get from 49 to 52, we're just going to add 3. So x plus 7 squared plus 3 is our equation in the complete and square form. Now what we can say is, well, if we've got this curve, this in the middle here, this x plus 7 is all being squared. So even if x is a negative number and this becomes negative, the squaring, negative times negative, this will always make this into a positive. So you'll keep going down, negative, negative, and then what's going to happen is going to go into positive, so it's going to go back up again. So it must be at the point when this equals 0, it can't go any further down. So because it's going to get a smaller negative, smaller number, and then it's going to go into a positive number. So we're going to have to make this equal to 0. And to do that, you've got to say, well, x equals minus 7, and then input that, and you'll have y equals minus 7 plus 7 squared plus 3. Minus 7 plus 7 is 0, so y is 0 squared plus 3, so y equals 3. So when x is minus 7, y equals 3. So at the coordinate minus 7, 3, that's the turning point, which is here. On the graph, it'll look something a bit like this. And that's it, paper 2 done. Bit of a marathon. We've got one more paper to go if you're going to watch it. But thanks for watching. I hope you found this helpful. Stay safe and healthy out there, and I'll see you in the next video.